Hi, everybody. Welcome back. So this is going to be, so this lesson on functional iteration with purrr is going to be basically almost our very last module for the course. And one of the reasons it has to come so late in the semester is because we have to have a very, very solid understanding of how vectors work and also a reasonably solid understanding of how functions work. Because the idea of functional iteration is that we are taking this ordered collection of objects, i.e. a vector, and we are applying a function. We're making that function work on each of the elements in that ordered set. So we kind of have to understand a little bit of the way the for loop works, even though we're not going to be using for loops. We kind of have to understand how a function works and how functions have arguments and how they return values. We have to understand how vectors work, the ordered collection of objects, before we can really start combining these three very advanced topics into this lesson right here. This lesson is very, very powerful. Like the material in this lesson is very, very powerful, but it can be hard to wrap your head around, especially if you've never seen stuff like this before. So the last lesson, we had talked about control flow. So we've got if and else statements, we've got while and break statements, and we've got for loops. We had talked about how a function works. Functions have arguments. They have a body of a function that has the expression of what the function does, and then functions return the very last thing that they do. And we had also talked about like best practices for writing functions. The functions should be relatively like simple, and they should do one thing. They should do that thing well. They should have their own documentation. You should, whenever you write a function, you should immediately test the function. Like all of this stuff we talked about over the last couple of videos in the last lesson. So what we want to do today is we want to kind of review some of the major topics in computing that we need to have a refresher on before we can really get into functional iteration. And so we are going to review vectors. Just the ordered collection of objects, just make sure we have our heads wrapped around those. Again, we are going to review functions. Then we'll get into the new material, and that is what is a functional? And we'll talk about how functionals can help us connect vectors and functions together in a way that allows us to do repeated or iterated calculation over a vector. And then we'll talk about how functionals are what allow us to apply functions to vectors. And then we'll talk about the data science strategy known as split, apply, combine. So that's kind of what we're looking forward to over this lesson. Like I said, this point of this lesson is to meaningfully connect functions and vectors. So we need to have a solid review of both. Before we move on, we're going to be looking at some stuff out of the Gapminder data set. We're going to be using the Gapminder version of the data, not the DS Labs version of the data. So install the Gapminder package here, and then create this Gapminder DF, which will be a tibble of our Gapminder data. Also, what I want you to do here, so Washington State University Department of Stats has an example on I think these are tornadoes, so data about tornadoes, and there's a folder of data. And so what I want you to do is, as an exercise, go and get this data and put it in the data subdirectory that you're using for this class, or at least for the project for the RStudio project for this class. Not related to you won't use this for any of the projects that we've done in this class, but the RStudio project that you use while you're doing the examples in this class. Put it in the data subdirectory and call it purrr example data with using snake case. And it'll be, I think, 10 CSV files will go into that folder. And then the idea will be that towards the end of the lesson, we're going to want to be able to import all of that data, all 10 of those CSV files, and do some work on those data sets. So that's kind of where we're going. Before we get there, however, let's review vectors. Okay, so we have atomic vectors. We often create atomic vectors with the concatenate function, just the lowercase c. And right here, we've got a numeric vector 1, 3, and 5. We can also make non-atomic vectors, and we remember that atomic had four classes that, well, I mean, technically six, but four that we care about. And in order of complexity, it's logical, integer, numeric, and character. And we said that all of the elements, so these vectors are ordered collection of elements. And for a vector to be atomic, they all have to be the exact same class, and they need to be one of these four classes. And that's what makes it atomic. And then non-atomic vectors was literally anything else, any other kind of vector that doesn't adhere to that restriction. So you could have atomic information in a non-atomic vector, but there's also other information in that non-atomic vector that comes from a different class other than logical, integer, numeric, and character. So we've got atomic vectors, we have non-atomic vectors, but the through line for both of these is that they are ordered collections of elements. And we had mentioned last in one of the videos from the last lesson talking about control flow, is that it's the ordering that allows us to do really cool things. It's the ordering, the fact that these are ordered sets, ordered collections of pieces of information or ordered collections of subobjects. The ordering allows us to assign numbers for their position. And once you can assign numbers to a position, so for instance, the 1 is in the first position of this vector, the 3 is in the second position of this vector, the 5 is in the third position of this vector. My first name is in the first position of the vector, and this is a non-atomic vector. My last name is in the second position of this vector. My age is in the third position of this vector. So the position of the position of the elements within this ordered set matter. And we said that this was important for for loops. It's also absolutely of crucial importance for this functional iteration. Without these positions, functional iteration does not work. So, but because vectors are ordered collection of elements, i.e. they have positions, then we can do this, what we're going to learn about in this collection of videos, and that is the functional iteration. Again, so the Gapminder data set, this is also, if you remember, this is a list, even though it says it's a tibble. If you use the type of command to find out what's the storage mode of this object, you will see that it is a list. And the first, second, third, fourth, fifth element are there are 6 columns of this tibble. And so the first element is the column for country, the second element is the column for continent, the third element is the column for year, and so forth. But again, there is an ordered collection of elements. In the case of a tibble, the collection just happens to be rectangular, but it's still an ordered collection of elements where all of those elements happen to be atomic vectors of the same length. And again, so going back to this, all of the elements of any vector can be assessed by their position because they are ordered collection of elements. Okay, this is one of the reasons why an environment is different. An environment is an unordered collection of elements. There isn't an ordering to an environment other than like the alphabetical order. Like you can sort the environment, you can sort the objects in an environment alphabetically or something, but there's not an intrinsic ordering. You can't say, give me the second element of an environment. At least I don't think you can. I'll have to try it out. I'm pretty sure you can't though. But a vector, the collection of elements, has an order to them, which means that the position, you can access a sub-element or you can access an element of that object, an element of that vector by their position. So you can get the first element here, the first element here, the first element here. And notice I'm doing single bracket subsetting. So I'm not trying to get inside of the object. I'm just saying, give me the first element, whatever it is. And this is important because we kind of go back to this lesson on atomic vectors, this lesson on lists and tibbles. The single subset operator does different things based on what kind of object is being accessed. So if it's an atomic vector, using the single subset operator on an atomic vector returns atomic information. If it's a non-atomic vector, the single subset operator also returns non-atomic information. If it's a tibble, i.e. list, non-atomic vector, and you use the single subset operator, you're still going to get a tibble, i.e. a non-atomic vector. So accessing information, accessing the elements of a vector by their position, that is going to be sort of like one of the two things that make this lesson go. So number one, that's what we need to remember from vectors. is that they are an ordered collection of elements, and we can access their elements based on the position. The next thing we'll talk about is the functions, and that is once we've accessed this component in the whatever position, what do we do with it? So next, we're going to stop the video here, and we'll pick back up with reviewing functions. All right, see you soon.